Now we are going to start with a unit that is the light. As you all know that light is very important because everything that you can see around yourself is just because of light. So what is light actually? Again, it is a form of energy, and you know that this energy actually help in producing the sensation of vision. So coming on to the light, so that means light is again a form of energy that enable us to see around us. That means it produce sensation of vision. It produce sensation of vision. Now, from where we get light? So obviously we get light from the sources. We get light from the sources. So we see that for example, here this room is bright because we have tube lights, we have bulb, we have so many lights here in this room. Likewise, when I go out, I can see everything around because there is a biggest source of light, that is the sun. So that means we need a source to see anything, because the light, obviously the light will produce sensation, but there should be any source which will emit that light, because when we'll get that light, then the light will fall on the objects, they will reflect back, and that reflected light just fall in our eyes and it makes the thing visible. So that means the sources are very important. We have two kinds of sources. We have natural sources also, we have man-made sources also. Natural light, as I told you, that biggest source of light is the sun. And you know that how far is the sun from earth? It is approximately 150 million kilometers away. It is approximately 150 million kilometers away, but still it is capable of, or you can say it just makes the day bright. So that means the light which is emitted from the sun is so bright, is so intense, that as you can see that it is too far, but still it can make the day bright. So that means sun is the biggest source. And how far it is from earth? It is 150 million kilometers away. And likewise, we have stars also. They also emit light. They have their own light. They are actually too far from, there are certain stars which appear bright, but actually they are not near to the earth. They are actually far from the, too far from the earth. That means they are approximately more than 150 million kilometers. That means they are far from the sun also. So still we can get that light, right? So that means the natural sources are sun, star, and likewise we have certain animals also which are capable of emitting the light. Like we have the light worm, commonly called as jugnu. You know that this common organism, that is the light worm, that is the jugnu, it is capable of emitting light. You must have seen, like when you get into a field or something at night time, you may encounter that there are certain kind of flashes of light. You can see that something is just flying and you can see the flash of light. That is the light emitted by the light worm. Now you must be thinking that how, like, we cannot emit such light, but that animal has an ability to emit light. So how it can emit light? How it can emit? What is happening inside it? That phenomena is called as bioluminescence. You can say as bioluminous also. You know that those organisms actually they carry out a chemical reaction in their body as we do a chemical reaction, but we cannot convert the chemical energy into light energy, but they can. So that means in them certain chemical reactions are carried out which is capable of converting the chemical energy into light energy. That is why they are emitting the light. This is the cause of light that is emitted by the light worm. So this is what is natural sources, the common sources, that is the sun, stars, there are light worms. We are able to see a bioluminescence kind of phenomena. So now what is bioluminescence? When the light is emitted by any living organism as a cost of chemical reaction occurring in its body which convert chemical energy into a light energy. So this is what is the natural source. Now moving on to the man-made source, we have also, like as with the modernization, we have so many man-made sources. We have variety of lights actually around us. So there are man-made sources also, like we have candle, we have lamp, and you must have seen that we get actually candles of variety of candles we actually get. It is not a simple candle we are getting a variety of candles. Like you will visit to a Nainital, you know that Nainital is actually famous for the candles. So there you can there you can see that so beautiful candles we found there. So that means man has actually reached to a peak where it can actually make anything artificially. So likewise we have sources also of light. So we see candles, we see lamp, bulb, tube light. So many sources are around us which are actually artificial, but still they exist. So that means sources of light is very important, because obviously if we are going to do anything with the light, we need a source that should emit a light. So this is what is the sources. Now, like as I told you, that sun is the biggest source, but it is too far, approximately 150 billion kilometers away. So how it is capable of making our day bright? How it is capable of making a day bright? Because this is an important question, because it is not too close to us, it is too far, but still it gives light to the whole, you can say the world or an universe. Everything is bright in the daytime. Now what is the reason behind? The reason is the scattering of phenomena, or you can say the scattering of light phenomena is occurring. See, as the sun is too far, like sun is here, right, and earth is here, or any other planet if we consider, there are a lot of gases which are particles actually which are present in the atmosphere. So what happens when light passes from these particles? You know that these particles actually show a phenomena of scattering. What they do, they actually absorb the light rays first, and after absorbing they just re-emit in all directions. This is what is scattering. So what is scattering? It is a phenomenon in which first light is absorbed and then re-emitted in all directions. So this is what is scattering. That is the phenomena in which the particles are actually capable of absorbing the light and then re-emitting the light in all directions. So this is the reason, as I told you, that sun is too far, but still we have air and there are a lot of particles which are present in the air. So what they do is they generally absorb the light which comes from the sun, and after absorbing they just split in different directions, and that splitting is called as scattering, which actually make everything around bright. So this is what is the scattering of light, very important. And if we talk about, as we get the light, you know that the light which is emitted from sun or tube light or bulb, so that the light also show a property, that is an important property, that is the intensity, which is what is intensity now? It is actually the measure of brightness of light. As you know that sometimes you encounter a dim light, sometimes you encounter a bright light. So the quantity which deals with the brightness of the light, that how bright or how dim is the light, is the intensity. So intensity is the measurement of the brightness of the light. Now obviously if you measure this quantity, so obviously this physical quantity must be possessing some unit. So earlier times the unit which was used to measure the intensity of light was the candle power, written as this. Like if I, like at that time the candle power actually means, like if I say that bulb is of 60 candle power, it means that this bulb is capable of emitting the light which is actually equal to the light emitted by 160 candles. Like if I say that a bulb is of 100 candle power, so that means this bulb is capable of emitting a light which will be equal to the light emitted by the 100 candles. So this is what is a candle power. But it actually doesn't give an appropriate, you can say, the measurement. So it has been replaced by another unit, that is the lumen. So the unit which we use to measure now the brightness of light, that is the lumen. And 1 candle power is actually equal to 1256 lumen. 1 candle power is equal to 1256 lumen. So this is what is an intensity. I think you got it, that what is light, what are the sources, and what like how like we are far from the sun, but still it makes the day bright all around just because of scattering. And moreover how we measure the intensity of the light, how we measure the brightness or dimness of the light, we do it by the term intensity. And how we measure it? By candle power, or now been replaced by with a lumen, and 1 candle power is actually equal to 1256 lumen, right? So this is what is a intensity. Now depending upon the source from which the light is emitted, we have further classifications also. Like we have hot and cold source. See, some of the sources which emit light, they are actually called as cold sources, and there are sources which emit light but they are called as hot sources. For example, if I talk of light worm, right, you know that light is emitted by a light worm. So if you'll touch that light or if you'll touch that jugnu, will you feel hot? No, we won't feel any hot, because the light emitted by the jugnu is not warm light, is not warm, it is just a light. So that is called, jugnu is called as, or a light worm is called as cold source, because it is emitting light but it is not emitting any heat along with that. That is why you are not feeling any kind of hotness. But if you will touch a glowing bulb, suppose you switch on the bulb and you leave it for a few minutes or something, and you just try to touch it. So will you feel the light? Obviously we can see the light, not feel the light. So we can see it, but will you feel the cold or the hotness? Yes, we will. Obviously we won't be able to touch the glowing bulb because it becomes hot. So that means it is emitting light also and it is emitting the heat also. So it is being classified under the hot sources. So likewise we have two kind of sources, that is the hot sources and the cold sources. So the one which emit light as well as heat along with it, they are called as hot sources. And the one, like as I told you about the jugnu, the light worm, that is emitting only the light, not the heat, and you can easily touch that light also and you won't feel anything. So that is called as cold source. Right. So if light is emitted from a source which is emitting just a light, not a you can say not heat along with it, that is called as cold source, and the one which emit both of it, that is called as hot source. Now we encounter many other objects also, like we have incandescent bodies. Now what are those bodies? There are certain bodies, like what you do is when you just when you heat them, they start emitting the light. So those bodies, they are almost all bodies around, all non-luminous bodies around, actually they are incandescent bodies, because when we heat them, that raises the temperature and they start emitting the light. So that means those bodies which emit light when heated to a high temperature, they are the incandescent bodies. Like we have an iron bar. So if you will just heat the iron bar, it will start emitting the light, the red light, and you know that at approximately 800 degrees Celsius, approximately around 800 degrees Celsius, it becomes red hot. It emits the intense red light. So that means that is called as incandescent bodies. So I think you got it, that depending upon the hot or you can say depending upon the temperature of the source, we have hot source, cold source, and along with that we have the incandescent bodies, which are not actually the sources, but we can make them a source. How? When we heat them, they emit light, right? So these are the incandescent bodies. So another classification of the source is that we have sources which are luminous and there are sources which are non-luminous. So like we know that luminous source is that which has its own light, For example, sun. It has its own light, and when the light of the sun falls on any non-luminous object, it just reflects it, and because that reflected light comes to our eyes, that is the reason that we can see that non-luminous object. For example, I'll just state with an example. Suppose you enter a room which is a dark room. So will you be able to see bed, chair, anything which is present in room? No, we won't be able. But if there is any tube light there or any bulb which is glowing, then will you be able to see that? Yes, we will be able to see the bed, chair, everything, all belongings of the room, we will see that. The reason being that when the light of the luminous falls on the non-luminous, it just reflects that light, and that reflected light reaches our eyes and it makes the object visible. So that means luminous is the one, like if you want to see a luminous object, you don't need any other thing around, because it is itself a source of light. But coming to non-luminous is the one which do not has its own light. It do not has its own light, but that means to see this non-luminous object, we need a luminous object around, so that when the light of luminous will fall on the non-luminous, it will reflect that, and that reflected light when reaches our eyes, it makes the non-luminous object visible. And you know that moreover there is one more thing, that you can actually convert any non-luminous object into luminous one. it sounds a little weird, but still we can actually convert the non-luminous into luminous. The reason how, that when you will just heat the non-luminous, so most of the non-luminous body becomes the luminous, they start emitting the light. As I just discussed about the iron bar, that iron bar is a non-luminous source, but when you will heat it, it will become red hot, and at a certain temperature it will just start emitting an intense red light. So that means we can make a non-luminous a luminous. That is how? By just heating it. So this is what is a luminous and non-luminous, and you should know that to see a non-luminous we need a luminous object around. That can be a man-made or artificial, but obviously a compulsory condition is that you can see a non-luminous when there is a luminous object around it. Likewise, we have a medium also. Now what do we call as optical mediums? Optical mediums are actually those which allow light partially or completely to pass through it. I'll write here. Optical mediums are those which allow light to pass whether partially or completely. So that means any medium like air, water, glass, diamond, silver, anything which actually allow the light to pass through it, whether partially or completely, we are not concerned with that. So that is called as optical medium. Now depending upon its density, we have two divisions of optical medium. One is the homogeneous, other is the heterogeneous. As you know that homo means same. So homogeneous medium is that which is going to possess the same density at all points. That means if you look for different points in that medium, you are going to find the same density. Like we have glass, silver, diamond, etc. They are all homogeneous. So at any corner, if we look for the density is going to be same. So that is called as homogeneous optical medium. That means it is going to allow light to pass whether partially or completely. And if we talk about the density, so density at all the points is going to be same. Other is the heterogeneous. Hetero means different. So it is going to possess different density at different points. So there are certain points where you will find that density is too high, and there are certain points where you will find that density is too low. So this is what is a optical medium, but still whether it is homogeneous or heterogeneous, they are going to allow light to pass through them. So there can be a chance that whether they allow a whole amount of light to pass through or they are just allowing a partial light to pass through. Only this matters. So we are just going to see another classification where we will see that we have different kinds of object, that is the transparent, translucent and opaque, just depending that how much amount of light actually they allow to pass. I think like for this moment I will just stop here, because just try to learn till here and then start on with the another the phenomenon that I am discussing, that is the transparent, translucent and opaque sources. But I think you got till here, you know that what actually we are going to study in this chapter. So you are familiar with the light now, you are familiar with the sources, natural and man-made, and please keep in mind that sun is too far from us, and approximately distance is 150 million kilometers. And this is what, and you are familiar with the man-made sources also. You know that how the sun is able to make anything bright, or how a tube light is able to make anything bright in the room. So this is just because of the scattering. And likewise I told you that we can actually measure the brightness also, and that quantity is called as intensity, and we have the specific units for measuring. And please do not forget that if I say that a bulb or anything is of 30 or 40 candle power, it simply means that it had a simple meaning actually, that the light emitted from such thing is actually emitting the light which is equal to the light of this much candles. So if I am talking about the 30 candle power, so that means light emitted from that source is actually equal to the light emitted by 30 candles, simple. But now it is being replaced by lumen, and 1 candle power is equal to 1256 lumen. So this is what is an intensity. And you must be, I just want to state one more example. Suppose there is a dark around, I'm talking about the dark time at night, and if you wish to play a badminton, so obviously you will be able to play a badminton just below the pole, that means near the pole where the light intensity is high, but you cannot play a badminton properly, or you won't be able to see a shuttlecock if you are not playing under that pole and you are playing far from it. So because as you increase the distance from the luminous object, the brightness of the brightness of the light just decreases. Obviously, like if there is a tube light on my head and I'm standing here, so obviously the brightness of light is going to be high. But if I move from this place to that place, so then what happened, I won't be like the brightness of light won't be that much as it was earlier. So just it matters a distance, like when you are near to the source, the brightness is more. If you are far, so obviously the brightness is going to be affected. Now, depending upon the another classification we just discussed, if it is emitting only heat and light both, it is a hot source, and if it is emitting only the light, it is a cold source, like Jugnu and this thing. And even you know that there is a measure of temperature, there is a difference of temperature also. Like you have a burning matchstick and you have a Jugnu with you, then you know that if you are able to touch the light that is emitted from Jugnu, you don't feel hot. But if you touch a glowing matchstick, obviously there is going to be a difference of temperature. So that is there we get to know about the hot and the cold source. Coming on to the next one, incandescent bodies, as I told you that when we heat them, they emit light, otherwise they are non-luminous. And we can actually make any non-luminous body luminous by just heating it, as I told you about the example of the iron bar also. So talking of the medium, so if somebody asks you about optical medium, obviously a medium is a substance which allow actually the light to pass through, no matter it is passing partially or completely, but still if it allows the light to pass through, it acts as a medium. So if it has the same density around, it is homogeneous, and if it has a different density around at different points, actually it is heterogeneous. Like we have air, fog, mist. So what do we observe in air, fog and mist? So we see that there is no uniform composition everywhere. It's like at different points, at some places there are more particles and some places they are far from each other. So that means the density actually changes with that. So we say that there are optical mediums where the density is same at all places, it is homogeneous, and if the density is different at different places, it is the heterogeneous. And now we are going to start with the translucent, transparent and opaque sources, because we know that, as I told you, that they allow light to pass, but light can be partial or completely. So just we'll see that. But before you do that, just go through this topics what we discussed, because every term we use here is an important term, right?